Welcome to lesson 1.1 in geometry. Today we're going to discuss points, lines, and planes, which are the building blocks of geometry. Okay, so we're going to start talking about what are called points, lines, and planes. So points, lines, and planes are considered undefined terms. This is because they can only be explained by using examples or descriptions. We're going to have to say things like points are like this, lines are like that, planes are like this, okay? So we're going to use some of these examples and some of these things that are in the real world that we see, and we can then explain what points, lines, and planes are. Okay, the first of our undefined terms is a point. So a point is just a location. It doesn't have a size or a shape. You might be familiar with some of the apps we have on cell phones, which show where we are relative to where our friends are. So that is designated by a little dot, a lot of times showing our location. So it's just where we are, okay? This is a three-dimensional concept. So a point could be where a ball is after it's thrown in the air at a specific point in time. So a point is just a location. All right, we name points with capital letters. An example here would be point A. We draw a dot and we put a capital letter next to it. And that's how we represent on a piece of paper or on a test or a quiz a point. And points are kind of thinking of them in another way like pixels on our screens. Okay, all the little dots that make up a screen, those are all those little points, those little locations. Okay, so a line is just made up of a bunch of points. It has no thickness or width. Okay, and this rule is something that you're going to have to understand and be able to use, and that's this one right here. There is exactly one line through any 2 points. This is an important rule because as soon as we have 2 points designated, whether or not it's drawn on a diagram, there is a line there. So we name the line either one of two ways. We take 2 points that are on the line that are named, and we draw a little arrow going in both directions, or we have just a lowercase, what we call script letter. So there's some examples here, line M, line PQ in symbol, or the words line PQ, or again, line QP, or also line QP written out. Either one of those would be acceptable based upon a given diagram. Think of a line like a path of a bullet that flies for infinity. If you're in outer space and you fire a bullet, that bullet will travel on a straight line for infinity unless it's affected by something we call gravity. So, a little physics there for you. Okay, so here's an example of line PQ. Okay, we said we can name this line a number of different ways, like we showed you earlier. This could be line PQ or line QP, and either one of those are correct. We can use either form to name that line. When we have just this lowercase letter, we usually just write the word line and then we write an M. Okay? Or you could write it like this. Okay? That's my writing. Okay, a plane is a flat surface made up of all the points that extend in depth infinitely in all directions. So there is exactly one plane through any 3 points not on the same line. So if you notice here, what you may see is that we have, if I connect these 3 dots, I have what's known as a triangle. A triangle is the smallest portion of a plane. Okay, so a plane is somewhat like the surface of a desk, a wall, a floor. Okay, all those things are examples of planes in the physical world. We name a plane by a capital script letter K or by naming the 3 points that are not on the same line. So in this case, we have plane K, and all these names would be correct if you were asked on a quiz, what are the names that we could call this plane? We would say plane BCD, plane DCB, plane CBD, plane BDC. All of those would be correct names. Okay, so we're going to discuss now some definitions. So collinear points are points that lie on the same line. Okay, they take up the same space per se in that they lie linear. Okay, they are linear. So we typically have it look like this. These points here would be representative of collinear. Non-collinear points would be a group of points in general that look like this. I might have a group of points just like this. But in this group, I've got one that's sitting like that. Well, the whole group is non-collinear then. Okay, they're not on the same line. Non-collinear, not on the same line. Again, when we represent a plane, we typically draw something that looks like this. And if I have points that are sitting like this, we would say those are coplanar. They're not on the same, excuse me, they are on the same plane. They are on the same plane. Non-coplanar, we would kind of represent it like this. So I might say, well, I've got these 3 points here, they're on the plane, but this one is clearly floating above. That is non-coplanar. That group of 4 points do not lie on the same plane. Okay, let's talk about intersection of lines and planes. So the intersection of 2 or more geometric figures is the set of points that they have in common. The sign for intersection, all right, the symbol for intersection looks like this. It's an upside down U. Okay, so that's the symbol for intersection. Okay, so that symbol is what we would use if we want to do this in a shorthand way. All right, I prefer not having to write the word intersection, and I think most of you would prefer not to have to write that out every time also. Okay, so the intersection of 2 lines is always a single point. Okay, so you can see here intersection between line L and line P, excuse me, line L and line M is point P. That's where they meet. That's what they have in common. Okay? That's the only point that's on both L and M. Okay? When two planes intersect, excuse me, is always a single line. Okay? So we can see here that this plane, right, is these two planes intersect, and you can see here that there is a straight line. The interesting thing is if you look in a room and you see where two walls meet, you'll see a line. If you look in a room, you can see where the two walls meet and you'll see a single line. Okay? All right. Intersection of a line and a plane. If you think about a line going through a plane, the intersection of a line and a plane, all right, is a single point. Right? You think about a pipe that goes into a wall, okay? And the pipe, you can see the pipe coming out of the wall, all right? The pipe is representative of a line, the wall is representative of the plane, and if you were to see where that pipe goes into the wall, there's a hole there. The hole would represent the intersection or that single point. Okay, next we're going to cover some defined terms. Now, definitions or defined terms are explained using undefined terms and or other defined terms. So I can use an undefined term to define another thing, okay? So this one here is called space. So our first undefined term is called space. And basically what space is, it's a boundless three-dimensional set of all points. So we are using the definition, the undefined term of points, to define what space is. Okay, so it's boundless, there's no end, which means it's infinite, it's three-dimensional, and it's full of points. Okay, so space is boundless, three-dimensional set of all points. Space also can contain lines and planes. It actually does contain lines and planes. Okay. There is an infinite number of points, lines, and planes in space.